Welcome to Math Mission. This question we have very few information, so only the area of the great semicircle is 12 square centimeter. The fewer information is given, the more challenging the question will be. It means that we need to reconstruct the figure with auxiliary lines to reveal hidden relationships. To determine the area of the quarter circle, we need to know its radius, which of course must be related to the given information, the area of the semicircle. But how can these two be connected? To make solution clearer, I will label the relevant points with letters. Let's assume the radius of the small circle is r, smaller r, and the radius of the large circle is big R. Now, we extend the radius AO to a point B such that AB becomes the diameter of the large circle. Next, we connect points A and C as well as B and C. Since the intersection point C lies on the circle constructed over the diameter AB, we can apply the angle in the semicircle theorem, also known as the Thales theorem, to conclude that the angle ACB is 90 degrees. Point D is the point where the semicircle touches the AO, namely AD is tangent to the semicircle. Therefore, the diameter CD of the smaller semicircle is perpendicular to the segment AB. Can we also determine some lengths of some segments now? Yes, we can see the CD is too small. It's the diameter of the semicircle, and AD is the big R minus the small r, and the DB is the big R plus small r. Now let's take a look at the right angle triangle ACB. According to the Pythagorean theorem, we have AC squared plus BC squared is equal to AB squared. AB is the diameter of the bigger circle, so we can write 2r squared. Can we express AC and BC also in terms of the big R and small r? Yes, in the right-angled triangle ADC, we can get AC squared is equal to AD squared plus CD squared. Here AD is r minus r and CD is 2 small r, so substituting these expressions gives us AC squared is equal to r minus r bracket squared plus 2 small r squared. Using the same principle for the right-angled triangle BDC, we also find that BC squared is equal to BD squared plus CD squared, and we can write in the big R and small r form. Now, substituting both expressions into the original Pythagorean equation at the very top and simplify them, it will just needs to r big R squared is equal to 5 times smaller r squared. From the problem text, we know that the area of the semicircle is 12 square centimeter, namely the full area is the pi r squared is equal to 24. Using this relationship, since the big R squared is 5 times r squared, we can determine the area of the quarter circle is 30 square centimeter. Therefore, the answer is D. Thank you for your watching. See you next time.